In the last video, we saw that each element can come in different forms called isotopes, which have the same number of protons but different numbers of neutrons. However, only one or two of an element's isotopes are stable. The rest are unstable and undergo radioactive decay, which means they emit something to change slightly and become more stable. So when we say a material is radioactive, we mean it contains unstable isotopes that can decay. In this video, we'll take a closer look at the four types of nuclear radiation: alpha particles, beta particles, gamma rays, and neutrons, and we'll cover how ionizing and how penetrating each of them are. Starting with alpha radiation. Alpha particles are made of 2 protons and 2 neutrons, the same as a helium nucleus, and are represented by helium's nuclear symbol, He. Alpha particles don't have electrons, so they carry a charge of +2. Because they're relatively large, they get stopped easily by collisions with molecules, so they can't penetrate far, only a few centimeters in air, and are blocked by a single sheet of paper. However, their large size and strong charge make them highly ionizing, meaning they can easily knock electrons off atoms. Next are beta particles, which are just electrons with a charge of -1 and almost no mass. Interestingly, beta particles aren't emitted from the atom's electron shells. Instead, a neutron inside the nucleus decays into a proton and an electron. The proton stays, and the high-speed electron is emitted. Because beta particles are small, they're moderately ionizing and moderately penetrating, taking several meters of air or a few millimeters of aluminum to stop them. Gamma rays, on the other hand, aren't particles at all. They're waves of electromagnetic radiation, like light, and are often emitted after alpha or beta radiation as the nucleus gets rid of excess energy. Since gamma rays have no mass or charge, they pass through materials easily and are only weakly ionizing. They can travel long distances through air and require thick sheets of lead or several meters of concrete to stop them. Lastly, we have neutron radiation. If a nucleus has too many neutrons and becomes unstable, it can simply emit a neutron to become more stable. That's neutron radiation. So to quickly recap, alpha particles are made of 2 protons and 2 neutrons and are stopped by paper. Beta particles are electrons and are stopped by thin aluminum. Gamma rays are electromagnetic waves and need thick lead to be blocked, and neutron radiation involves the ejection of a neutron to increase stability. That's everything for this video. If you found it helpful, give us a like and subscribe, and I'll see you next time.